So we've talked about multiplication of fractions, and we did some activities where you learned that you could multiply straight across the top, straight across the bottom. We talked about how you could simplify before you multiply. And the most important thing we learned about multiplication is that it answers the question, or you use it to answer the question of. So what is half of 1/4? Well, we would know that that's a multiplication problem. What is 1/6 of 12? And 4/5 of 9? And you've gotten to the point where you can easily figure out that this is 1/8 across the top, across the bottom. This is 12/6, which we know simplifies to 2. And this is 36/5. Multiplication says it answers the word of. Division answers the question, how many are in? And you did an activity in class where you had different sets of fractions, and you had to figure out how many sets of 1/2 could go in 12, and how many sets of 1/3 could go in 2 and 1/3. And so you began to work through those problems, and you're here today to figure out exactly how it is to answer those questions. So today in class we talked about building with a model, and now I just want to talk to you about some other strategies you can use if fraction towers aren't available, or if they're too cumbersome, because fraction towers aren't typically made with 14ths, and to get 30 of them, you might be able to figure it out before you got to model it. So our first one is to look for easy division problems. I remember how much excitement there was when we realized that to multiply, we just had to multiply across the top and multiply across the bottom. And I'm here to tell you that sometimes division is that easy. 2 of 3 of these are easy division problems because you can divide across the top and divide across the bottom without having a remainder. They're evenly divisible. So let's find those, find the answer, and talk about why the next one does not work. 30 divided by 2, straight across the top, is 15, and 14 divided by 7 is 2. And so the answer to this division problem is 15/2. Now, if you were going to answer the question, how many 2/7 are in 30/14? Well, the answer probably best would be answered as 7.5. 7.5 sets of 2/7 makes 30/14. And if you just listen to what I said, 7.5 sets of 2/7 makes 30/14. That's multiplication. And multiplication is the inverse operation of division, can always be used to check it. And so if you multiply across the top, you can indeed get what you had over here. How about this one? 5 divided by 5 is 1, and 9 divided by 3 is 1/3. And so we ask ourselves, how many sets of 5/3, or how many sets of 1 and 2/3 are in 5/9? How many sets of a mixed number are in a fraction? Well, the answer has to be less than a whole, and indeed it is less than a whole. Multiply across the top to check it, and you've got it correct. 18 divided by 1 is 18, and 25 divided by 5 is 5. So how many sets of 1/5 are in 18 25ths? Well, indeed the answer is 3 3/5 of a set. Now, I did tell you don't have to convert them into mixed numbers, but to answer the question, it kind of makes it easier to think about what your answer would be. And then look at this one. 9 divided by 3 is 3. But 7 divided by 14 is 1/2, or 7/14. And so we did not really create ourselves an answer over here, but rather we created ourselves another problem. And so when I say look for easy division problems, it's not something that you're always going to find, but understand that you could easily do some division problems if dividing across the top works. Now let's go for what if it doesn't? Well, if you can't divide straight across the top, then maybe we could find common denominators. And these are really fun to do because you get to see how numbers really go together. And so look at this one. 4 divided by 2 is 2. And 7 divided by 7 is 1. Well, how many sets of 2/7 does it take to make 4/7? And the answer is it takes 2. I don't even necessarily need this. So if my denominators are the same, then I just have to divide the numerators. Are you wrong if you divide the denominators? Not at all. It's just that you won't need to because of that. So some other common denominators. Here, these are exactly the same. So again, we can say 5 divided by 5 is 1. Here's another one with 9/5 divided by 3/5. 5 divided by 5 is 1, which means you can put a denominator of 1, or you can know that that is going to not be necessary because it is a denominator of 1, and do 9 divided by 3 is 3. How many sets of 3/5 are in 9/5? And the answer is 3. Now, this one, the denominators are not common, but if I rewrote this, if I renamed the fraction 1/3 to have a denominator of 9, then I could do 3 divided by 1 is 3. Because how many sets of ninths are in 3/9? And the answer is 3. This one, 15 divided by 5 is 3. And 16 divided by 3. That one does not work as far as an easy fraction, but if I changed my denominator so that this could be 15, then I would get 15 divided by 15 is 1. So my denominators are the same. And now watch how cool this is. 16 divided by 9 equals 16 divided by 9. 16/9 is the answer to this because across the top is the only place you have to divide when your denominators are the same. So let's change this to be 2/4 so that it matches our denominator. 2 divided by 14 equals 2 divided by 14. Simplify it to 1/7 and that's your answer. So writing the division problem from using this to using the fraction bar changes it to the problem to your answer. And so 13 divided by 7 when both of these are 6 is 13 divided by 7. And if you remember, the one we did in class was the question 1 divided by 2. And when written with the division bar, it tells you the answer. 1 divided by 2 equals 1/2. That's why this is the division bar, and there's just more than one way to read it, but they mean the same thing each time. So, this for sure is what you are going to see the most often. It's called stay, switch, flip. And the dividend stays, the sign switches, and the divisor flips to the reciprocal. Now that's a lot of vocabulary word. If you remember, the dividend is the one that comes first. The sign, being division, switches to multiplication, and the divisor flips to the reciprocal. Well, that is a fraction that's going to actually flip. And a reciprocal is defined as the number you multiply by to make any number equal 1. So what do I have to multiply by to equal 1? And I made these division, and they should be multiplication. So let's do that, because that is your reciprocal. And if you'll remember, multiplication means groups of. So this says 2 groups of something equals 1. And that is 1/2. And if you can see, this used to be 2/1. That's an understood value. And we flipped it to get 1/2. And when you multiply them, they make 1. We did this in class. Hopefully you remember 3/5 to find the reciprocal is 5/3. And you can see these equal 1 because if you simplified them first, they would all turn to 1, or simply multiplied across the top 15/15. And then this one, in order to find the reciprocal, it's most important to make it a fraction. So you have to write this as a fraction when indeed now it is a mixed number. So I'm going to turn this into 8/7. And when I flip 8/7, I get 7/8. So a reciprocal is taking a fraction and flipping it so that you can make a number that multiplies to equal 1. And that's the strategy we're going to use for the rest of the time we're dividing fractions. So let's practice stay, switch, flip. First, we have to fractionize just like we did with multiplication. So this problem is going to become 5 times 1 is 5 plus 3. We're going to do 8/5. That's fractionized. Flip or switch this and flip this. And so 8/5 times 8/7 will give us the answer. How many 7/8 are in 1 3/5? And the answer is 64/35. The common factors of 64 and 35 are 1. So that means it is in simplest form, and I don't have to turn it into a mixed number. Let's try here. 5 times 3 is 15 plus 2 is 17/5 times 10 times 1 plus 1 is 11/10. I have to, let's see, we'll fractionize it first. 11/10. And now we will stay, switch, flip. Now again, because this is a multiplication problem, I can use the rules previously learned about multiplication, and I see here that I have something I can simplify. So this is 1, and this is 2. 17 times 2 is 34, and 1 times 11 is 11. 34/11 is the answer to the second one. Let's try the next one. 3 3/5. This is 15, 16, 17, 18/5. Switch to multiplication. Flip to the reciprocal. 4/3. Look for something to simplify. 3 and 18. 1 and 6. 6 times 4 is 24. 5 times 1 is 5. Now, this video does not have a show what you know, so I'd like for you to rewrite these problems right now as improper fractions, and then come back and check your work. Use this time to really make sure you understand what you're supposed to do. So again, fractionize them, stay, switch, flip, simplify, and multiply. Let's see how you did. We're going to rewrite these problems as fractions instead of mixed numbers. So 13/3 divided by 5 times 1 is 5 plus 4 is 9, 9/5. That is my fractionized step. Now we're going to stay, switch, flip. 13/3 times 5/9. And then we're going to look to simplify, which 13 and 9 and 3 and 5 have no common factors other than 1, so we don't have anything to simplify. And then we're going to multiply. 13 times 5 is 65, and 3 times 9 is 27. I wanted to make sure to put some bigger numbers on here so that you don't feel like it's wrong just because your numbers are big or just because you weren't able to simplify. A lot of times textbooks provide problems that allow you to practice simplifying, but just because you can't doesn't mean it's wrong. So let's try how you did on the next one. Eight and 3/4 divided by 1 and 1/4. So let's put them in fraction form first. 32 plus 3 is 35/4 divided by 4 times 1 is 5/4. Now let's do stay, switch, flip. 35/4 times 4/5. Looking for something to simplify, and we indeed have two things we can simplify. This one we can simplify the fraction 4/4. So we're going to make these ones, and we can simplify the fraction 35/5 by dividing them both by 5. So this is 7 and this is 1. We did our simplification, and now our multiplication leaves us with 7 times 1 and 1 times 1, and so the answer is 7. All right, last one. All right, 3 and 3/7 divided by 1 and 1/6. Fractionize is our first step. 3 times 7 is 21, plus 3 is 24. 24/7. divided by 6 times 1 is 6, plus 1 is 7, 6. And now, this one looks like we can simplify, but watch, the directions are stay, switch, flip. And so 24/7 has to stay times 6/7. Simplify. 24 and 7 and 6 and 7 cannot simplify, and so we have to multiply. So 7 times 7 is 49, and 24 times 6 is 144. And again, the only factors that 49 have are 1, 7, and 49. And because 144 does not have a factor of those three numbers, the greatest common factor they share is 1, which means that this is in simplest form because the numerator and denominator are relatively prime. Dividing fractions. Fractionize, stay, switch, flip, simplify, and multiply. Or the other two tricks we learned at the beginning, if you can, find a common denominator and divide, or just divide straight across.